Alright. Okay, so... Alright, so now we have to actually move on from our thing and create some new files, since we just finished the decoder yesterday, like the basic logic for it. Obviously I'll rewrite because like it's kind of sloppy right now, but probably rewrite into like enums or like a std map or something. But yeah, we need to create an interpreter now. So yeah, we will try and do that. So first let's create a file. We'll call it interpreter. And same with the header file. Add an item. And that will also be here, just to have some forward declarations and stuff. So yeah. Let's see what we need for the interpreters to start. I've been chatting a bit with Claude, doing some research and stuff, so yeah, we can set up our struct for the course. Vector. Do we need IO stream? Yeah, that's okay for now. And then we need students for our unsigned values. So let's start with the struct. So we have the struct for the course. For a single execution unit, so we need a student array, and we assign int and 32 registers for the value. Just initialize it like that. Then we also need an integer program counter and a core ID. Doesn't care about the assignedness at the storage level, whether a value assigned or unsigned is determined by the instruction operating on it, not the register itself. Yeah, each instruction is separate for signed and unsigned, so that's fine. Try to answer correctly. Let's just give Claude away as a full bar. Two-minute model before writing an executor. Register x0 is hardwired to 0. That means no matter what the instruction tries to write to it, it always reads back as 0. Okay. So yeah, that makes sense. Second question, your registers are 0 initialized by default with std array, but should program counter start? Okay. So like it's like for setting the registers, like so if we do like a set register, so we have the register number itself and the value that we're taking in. So as long as register x0 is hardwired to 0, so we have to put this statement. So like if we have like so the register number, as long as it's not equal to 0, we can set the register number equal to the value that we wanted to set to. I think let's give this to Claude and see what it thinks about that. Operating on registers belongs to core. Does it make sense as a standalone function, or should it be a member function of the core struct? I actually don't know what member functions are yet. I'm not there yet, but essentially, they're just functions that live inside a struct and have direct access to its members. Oh, okay. Yeah, I was gonna write the get register after. Or I think it's better to write register and then have read register. I think that's more of an appropriate name, I think. Or let's just call it reg, so it's easier for me to type. So I don't have to type out register every time. I should understand it. So for creating a function like for reading it, so first we want to get the register number, and I think that's it. Just returning that value. Or not what? Oh, unsigned empty. Yeah, that works. Let's see. Do we need to think about anything else? Reading. Any special case for reading that mirrors a special case for writing? Is there a special case? I don't think so, right? Not exactly sure. Let me see. Yeah, I don't think we do. Since right reg prevents anything from writing to 0, yeah, that's the only thing that we need to take account of. We already took care of that. 0 initializes as read reg 0. Naturally, always return 0, yeah. Yeah. I mean, it's in the core struct. And let me explain why, because each core needs its own what's the word? Its own set of registers and its own program counter. Something like add I. Okay, so executing it. Oh yeah, and this should be in the header file, not here. So let's think about it for a second. So, okay. So for add I, so you have destination register, registers RS1. Okay. I think I can try. So we have void. I'll just write what's there and then implement decode instruction like a function from before in our struct code instruction, decoded instruction. so we need to include our header file here as well. Decoder.h. Okay, and so for reference of this, all right. Since we already had type like defined earlier, is there a way to actually like access them? Yeah, it's probably better to implement enums instead. Down a specific instruction name eventually to type by. Just tell you, okay, yeah. Okay, so I think we have to take a little break from this for now. Just comment this out for now, because we need to refactor this file to implement enums instead. Okay, so what was I gonna ask it? I think we should go back to our decoder.cpp. I know what they are, I just don't know implementation properly, so we're gonna have to learn some enums today. Yeah, so in class color red, green, blue, color C equals color red, and if that, so like, okay, that's pretty simple. Class purchase means the values just go not just red. Yeah, that makes sense. I mean, that's pretty similar to like to see how like you need like this to get the where it's from in the header file, and then telling us that the cout is from that. I'm pretty sure it's similar to that. That's just an observation I made. I don't know if it's actually like the same though. Instruction type. name string field. I mean, they should live in a header file, right? Low key, I'm probably not gonna have to write all the instructions. So I'll probably ask Claude to generate me all the instruction, like the names, because I don't want to go through and write all the names. But for types, we'll just write it simply. So like instead of these inline consts, so like it's like enum class instruction type, right? Is that what we wanted? Yeah, instruction type. And then setting each one. So like wait, so how exactly? You don't need the so is it just like names like this? So I R like all the types like that. So we mean so like we'll just go over IRF shift E J U I think that's how you do it. Let's see if that's what Claude was saying. Yeah, I'll remove the inline const. I just want to know if it's right. Goodbye, inline const. Why is that going wrong? Let's keep this in here for now, not gonna lie. Okay, as we fix everything, we need to see. Update the type field and decode instruction from string to instruction type. Yeah. So like that. Reference. Let's just get all of it that we had. And we have to refactor everything, dude. I just don't want to write all the names of these like instructions, so I'm gonna have to just ask Claude for that, because I'm not gonna write the enums for that, dude. Yeah, okay, this will be better. I think he covered everything. All these are types, this type. Yeah, it looks like he covered everything. Alright, that saves me at least like 5 minutes of writing this out. Yeah, now we just need to change stuff. So instead of this being like this, instruction. Do you just call it instruction? Yeah, so instruction name. Right. Now we need to change all this. So much broke, bro. So, yeah. Low-key don't want to change all of this, bro. But I guess I should. Yeah, I'll do it. Yo, what's good, Liquid 3XB? So basically I'm just making like well, first I made a instruction decoder. It's like basically takes assembly code and then it takes like a binary string, 32-bit binary string, and converts it to assembly instructions. And we're also working on the interpreter as well, but I just need to refactor all of this so I can like make it much more clean, because like right now I have like a whole block of if and else ifs, so I'm just making it simpler to read right now. So that's why I'm implementing enums instead, so it'll be easier to access them. And Claude handles C, C++. Like I'm mostly doing all the logic myself, but I'm just asking Claude to help me with like understanding it. So like mostly it's not really giving me much code. Like mostly I'm just writing the code and asking it if it's good, what I need to implement and stuff like that. I think if you ask it to like give you like a whole block of code in C++, it's not gonna do good at all. Because I don't think Claude's designed to handle that yet for C++. So yeah. Yeah, thanks, I appreciate it, Liquid. Alright, so oh, you don't write C, you've been using it for Python and JavaScript? Yeah, it's really good for Python and JavaScript, yeah. I've also used it for those too, but yeah. Now you're making crazy stuff? That's nice, bro. Nice to hear. I'm just trying to learn what I can. I'm only like a second year student right now, so I'm just trying to build up what I can. Alright, so Control H, let's see. Let's go back to here. So what do we need to replace this with? So type I. You love watching these streams? I appreciate it, man, appreciate it. I'll just keep streaming every day for this, so we'll see how far I can build this to, and eventually it'll be a really good project, so yeah. Alright, so open find and replace. We need to replace each instruction, so add I needs to become instruction add I. Oh wait, no, we have to do it individually. We can't do a find and replace because they're all separate. Okay. Low-key, I might just ask Claude to just add it in because I don't really feel like going in and replacing all of these, to be honest. I'll probably just save 5 minutes by asking Claude to do it, to be honest. Pretty sure Claude can handle that. If it can't handle replacing variables, bro, I don't know. That would be kind of sad. Gotta go to bed soon? Alright, man. Glad you came on the stream. I know, but I don't want to do it by myself, bro. It's gonna take just an extra, like... Claude's... Because the first prompt I gave it, Claude's actually, like, resisting. Whenever I ask for code blocks, like, it resists against me, so... Save some time. Thank you, Claude. I appreciate it. No, mine never tells me to go to bed. Like, it just keeps going. I have to tell it that I'm just gonna take a break for today. Alright. Hopefully, it kept everything the same and just changed the variables, because if any logic changes, that might be a problem. So. Hopefully it did not change any logic. So... Wait. Oh, okay. It didn't, like... format correctly. What's an easy way to format this back? Like, I low-key don't know. Okay. KF. It did not do that, so it did not format. Or maybe I'll just format this part. Maybe if we delete this one. Then format it. I never usually have these formatting issues, so I don't even know how to handle it, bro. Or is this like, dude, what the fuck? Alright, revert back, bro. Revert all the way back. Alright, let's go back to this, bro. Let's copy this properly paste it in. So now it should replace all the variables properly. Alright, there we go. I don't know why we struggled with that for so long. Alright, now it's actually properly formatted properly. And we can get rid of these two. Oh yeah, I didn't put in my type. Okay. Let's hope that Claude didn't change any logic, and then, well, main should be easy to refactor. It's just, okay, it's just like that. Alright. Same for the rest of these. What was that one again? Oh, J-type. Same for U-type, and then a couple more. Shell R. Environment, and lastly, well, that one's just like that. Is it like that, or like, how does that exactly work with enums? No, this is the same, so. has to be some little thing that's wrong. That's not working. Oh. Okay. So I need to write the case for every single one. Alright, Claude, I'll write it myself if you want to be like that. So we need to get the instruction to string. So it recognizes that the enum can be printed. Okay, I'll abbreviate it to C here. For each case, you just return that. Okay. How come it moved it there? I thought it's supposed to be like tabbed in. Let's tab in. Why is it like being like that? ask Claude why it's like moving it randomly like that. I guess where everything's right. Or what was it originally like this or something? I mean, it's fine. If it doesn't make a difference, then it's fine. As long as it's like working. I don't really mind. Edit it whenever. Hopefully this doesn't take too long because I kind of want to move on to the other logic parts. Actually, you know what? I'm probably gonna low-key, I'll outsource it, bro. I'll outsource it to Gemini. If Claude doesn't want to do it for me, I'll outsource it to Gemini. Let's get Gemini to do it for us, bro. Because I do not feel like writing out every single instruction, bro. All right, let me just give it like a basic like format to go off of. Alright, thank you. Claude doesn't ever have to know that I did this. Then we'll ask Claude, and we'll show it what I wrote. What'd you think, Claude? What'd you think? Appreciate that. I totally wrote that. I totally took up 30 minutes, 20 minutes of my time to write that. Alright, now I can actually finish. Thank you, Gemini. Alright. Yeah, I need to declare it. And the decoder.h. Oh wait, do I need to? Well, I guess it's probably better to move this out of main.cpp. I forgot. I don't know why I wrote it in here. That's just for IO stuff. That shouldn't be in there. We'll put it in a decoder. Then we will put the header file. Instructions string into that name. I know I could have just done a replace all, but it's fine. It's just a couple. Here, I'll just... Okay, I'm just gonna write unknown. Or wait, no, I think you can also just write... I think this also works for this too, I think. Let's check. Like if I do some randomness. Yeah, it works, I mean, it's fine. Okay, finally refactored, so now we have an enum class to store everything and appropriately print it out. So now we can put the decoder behind us for now and move on to the interpreter and continue off there. Right. Yo, I appreciate it, UDS Minecraft. I will keep streaming every day and see how far this project can go. Alright. Alright. So... So we have the decoder header file in here too. So now we need a way to actually execute the instructions. Let me comment. Execute the instructions for the register. Let's see. Alright. It's switching on inst.name, instruction.name to decide what operation to perform. It's from instruction to string, which goes from instruction to string. What makes enums specifically the operations destination register, source register 1 plus immediate. in terms of your core member functions, that would be okay. Let's start with I-type. So I-type, for the most part, so we have the instruction name, destination register, source one, just like it said back there. So it would be like if the instruction type is that value. So if it is I, or is it better to do a case switch here? Switch case here. Yeah, probably a switch case. It's probably better here. So if we have a switch, type, in our case, be instruction type. Starting with add I. Or no, wait. So I, right? Right. Oh yeah, we need a colon here. As you can see, I don't really use switch cases that much. Like, I never really use them that much in Python either. So then we can store it in like a, so like an unsigned int value. You can store that in like an as a result. And then, well, first, actually, yeah, we can just do it like this and just write the version. I don't think we have to read it first. Like that. Pretty sure that works. Okay. Why does that not work? Let's think about it. So, too many values, my bad. No, that's fine. Why is it like, do we need like parentheses around this or something? Are we not allowed to do that? Like, I thought we were allowed to do this. Let me ask Claude why this doesn't work. Why does this not work? Well, I'll get to that, wait, but... Oh, it's a void, right? Okay, so we can't do that. Oh. It's so tight. I mean, generally it's all the same. Okay. I guess we can. Right. Never mind. Should keep it void. But then how do we... Okay, we don't need like a... We don't need to store it. Okay. Oh, would it be? Oh, you're right. It's different. Yeah, so we can't do it by type. We have to do it by the actual instruction. Okay. Hey. So we can do it like that. My bad. The instruction. And we have to do it separately for each one. This is gonna take a while. Let's just do a couple today and then we'll carry off tomorrow. We'll continue tomorrow. We'll do maybe just I types today. A couple of these I types. I type arithmetic instructions and we can probably call it a day, continuing off tomorrow. Okay, buddy. Alright, okay. Okay. So for the case of ADI, we have the destination register, source register 1, and the immediate. Then case of and I, it's gonna be a little bit different than that. So it's gonna be the destination register again, but instead of addition, and here. And the same for I and going further. So it's actually not too bad. It's pretty simple. Just have to write it for every single one. So, what's the next one? Exclusive OR. Exclusive OR. Set less than. Set less than immediate is okay, that's quite a weird instruction. Let's see. So yeah, if the destination source register, the register source 1 is less than the immediate. Wait, how do we get that in here with that? Without making it too cluttered. Maybe you can write some logic here. Hold up. So if wait, no. What's a good way to do this? Wait. I'll probably just write something. If Claude does not like it, then let's just give it a shot. Like, is that even possible? Like writing if statements for like the parameters? Like, I just don't think that's possible. Hold on, we need to consult. We need to consult with Claude. Let's just copy the entire file. Oh, yeah, you're right. We need to break after each one. Okay. Yeah, I know I copied it, but like I'm gonna rewrite it. Okay. definition. First one. So if our source register 1 is less than our intermediate, it will be 1. Our destination source register will be 1. Is that how you do? Or no, let's just have 1, 0. And then here, instead of having all this, just get the results. It's probably better. Oh, what was? Oh yeah, okay. All right, there we go. I totally forgot. I've been putting it on. I've been putting it on the header file by accident. I need to move all this up into here. Should be better now. Wait, what's the problem? Like, we don't need all this. Keep it there. Include our header file. So for every single one, should be 4 since. Yeah, Rafa, I got that now. I'm still pretty new to C++, so like I'm still trying to figure out all like the little nuances and stuff like that. Okay, so this should be right. Let me just check the logic with let me just check the logic with code. The double colon. So I'm pretty sure it's like for, like I know exactly, like if you have like in a header file something declare like, this would be like the namespace, right? So like yes, this is the namespace and this is like the scope identifier, I'm pretty sure, and then this is like where like the actual like instruction, I'm pretty sure. So like the scope identifier, before the scope identifier is the namespace and then the actual like variable name. Let me know if that's correct. If not, I'll look into it more. Still have a bug. Is the register number not the value inside of it? Wait. Is there R1? RS1 is the... Got it, got it. I appreciate that, Rafa. I mean, I still have like a lot to learn. I'm only still on chapter 6 in Learn CPP. So like I'm just reading and building. And I find that like building actually helps me like understand the little nuances. So it's not just like me memorizing stuff. Okay, wait, so let's see what the problem was. So is that not right? Yeah, of course, I got you. Like mostly like the logic itself I'm trying to write, it's just like whenever I have questions, I ask Claude. Like if I don't understand a certain thing. So in a way, like it is vibe coding, but at the same time, it's like a different way of vibe coding, I guess. Wait, so yeah, it's the number of the register, but how do we actually... okay. We have to actually like read the... Okay, we're reading the register. So we actually extract the value from that. Okay. Okay. Why do you write it like this? Like, what is... okay. I just didn't know it's used like that. I usually just write static cast. So I guess I learned something new. So you can also write it like this, and it's like a way of static casting. Gotcha, Rafa, gotcha. What's like better? Like, is this like fine to write it like this? Because like, usually Learn CPP says to write it with static cast. So, like, what's the more conventional way of writing it? I guess just writing static cast entirely, right? Because like, this might be confusing for... Oh yeah, we can't have signed values for that. The value is stored inside of that. So static cast is safer as part of the standard library. Alright, makes sense, makes sense. Yeah, so I guess I'll just write a static cast. Wonder why AI would say to use like that then. And value inside here, or is it inside the thing? Is it like the value T like that? I'm pretty sure that's how you do it. Well, I wouldn't know why it's safer to use it, but well, yeah, I guess we can ask Claude. Well, right here it says, okay, so static casts are preferred because it's more explicit and easier to search for in code. Sure you can see. Okay, so yo, I appreciate it, Rafa. Yeah, it's gonna take like a year and learn everything, like computer architecture, operating systems, C++. I mean, that's what this project is based on. It's based on computer architecture, since I'm reading one of the books for it, and we're just building. It's hard to write accidentally. to force you to be deliberate about it. Searchable, safe and ambiguous cases. These casts are actually a hierarchy of up to different kinds of casts tread in order. Oh, okay. So this like requires you to use the actual specific type of cast, and if you do it wrong, it will throw an error. Got it. Oh yeah, we also need this in parentheses too. The full value. Using static cast makes the compiler check first, so might as well use it. Okay, yeah, that makes sense now. That's actually pretty nice to know now. Learn something new. Oh yeah, let's get rid of this. I actually want to take a look at add I, not add I. What was the one we were doing? It said less than immediate, yeah. Destination register, so oh, okay. I actually have the code right here. The explanation of why. So these actually take the register values, but these take the value inside of the register, which is why we need to actually read to that value. And it's the same for the other versions of it, the unsigned version, but just this one has an unsigned RS1 value, so we don't need to static cast it. Okay, we can write the next case. So shift set less than immediate unsigned. So we no longer need our static cast here because it's an unsigned version, so we can stick with that. And we just need to read the value and set it less than. Hey, what's up, Striggity? Hopefully I pronounced that right. Yeah, we're doing a project on risc-v because I'm currently reading a book about it, Computer Organization and Design by Patterson and Hennessy, risc-v edition, so whatever we learned in there, I'm just trying to implement in here. Well, would we still need it unsigned? Because like, let's go back to our code, right? So it's up here. For RS1 values, it's up here somewhere. It's our automatically unsigned int in the function itself. So I don't think we need a cast, right? Yeah, it'd be redundant. Yeah, that makes sense. Because the value is already unsigned int. And let's see the logic. So just fine. So it's just the same logic, just unsigned version. So yeah, this should be right. Everything looks good. Okay. We move on to the next case. The next case will be... Okay, so now it actually changes. So our format changes to shift types. So one more CPP fun content architecture stuff. Watch Coding Jesus. Yeah, I watched Coding Jesus. All like his all those like call-ins and stuff, like those are very interesting. And that's what got me to actually like start with this stuff. Look into graphics programming, yeah. Like I saw like this one guy on Coding Jesus' channel, like Tokyo Spliff or something. He does like graphics programming and it looked pretty sick, I'm not gonna lie. Yo, appreciate it, Rafa. Recommended channel called Esarola. Okay, I'll take a look at that. But we gotta go one step at a time. I don't want to like take up too many things at a time. So like right now, architecture and TPP for now, and we'll branch out as we keep going. All right, so shift left, logical. So in the case of this, so now the immediate is split up into a func 7 and the immediate. So let me go back to the logic and check exactly. We'll be taking a shift out now, so yeah, we need to use a shift amount for this. So let's see. So format would be, we're still putting it in a destination register, and we're taking the value from register source 1 and shifting it by a certain amount and loading that value into destination register. Okay. Okay, so we wouldn't need this case anymore. I'd just be writing, so it'd be like destination register reg rs1. So we're taking that register and we are doing a left shift by the shift amount. I think so. If I got that right, we'll just check with Claude and make sure that I'm on the right track for this. Shift left. Oh, bug in here. Oh, did we not? Okay, wait, the static cast moves to here. Wait, did I not catch that earlier? Wait. Oh, okay, that's right. Okay, so in the case of this one, we had assigned register source 1, but just regular int immediate signed integer. But in this case, everything's unsigned. I forgot about that entirely. So I forgot, since our usual value for immediates are always the signed version. So we need to do a cast, and for this one. Yeah, that should work. looks right here. So let's see if my other logic is right. So that looks correct. Nice. We actually got the. We got it. Got it first try with SLI. Shift left logical immediate. Okay, the next one is shift right logical immediate. So it's gonna be the same logic but just the extraction operator instead. So I'll just copy the case and make it SR, and we'll be reading the same stuff. Next should be this one, SRAI, which has shift right arithmetic immediate. How does that differ from logical immediate? Let's see. Let's do a little analysis. Let's go. Okay, so if you have a logical right shift, 0 shifted into the upper bit, yes. If it's arithmetic right shift, the original sign bit is copied into the vacated upper bits. Okay. So, wait, I'm having trouble understanding. So I know like this changes to 1. What exactly are we like looking for here? Let's get some water. Okay, so Funk 7 description them and the coding. By the time you're in execute, that section has already been handed to you. What exactly are we casting here? I got SRLI, right? That's right. But for this one, what are we casting? Let's see. So because we're shifting the sign bit. Okay, I need like a more of an explanation on this. So we're moving to the right, filling it with 0, so with an arithmetic shift. Okay, so we shift by 1. Okay, we're filling it with a 1 at the end. for the shift to preserve our. Oh, okay, this is for signed values. Okay. So. What if we double cast? So. Zeros. Yeah, that makes sense. We interpret the bits as signs, so C++ uses arithmetic shift. Interpret back to unsigned for storage. Okay. Okay. So we want the arithmetic to be done first by that, but then we still need the value unsigned at the end, so we need to change it back. Okay. Alright, got it. Alright, so. Static cast. So inside we need the bits to be changed here to represent an arithmetic shift. Then we also need to cast that again. Cast that entire sequence again. I think that should be right. Yeah. So that should be good. And does that end with the... Okay, that finishes all the I types so far for those. Alright, that's good. That's good. Okay. Let's see if we can implement a couple more before finishing up this stream and continuing off tomorrow, but let's see if we can... Let's try and implement some R types now. Or should we just finish off the rest of the I type? Because there are other I types, but in different instructions. Let's just do R type for now. Doesn't really matter like the format of where they're located as long as they're all there. So for the add instruction, it will be different. We have destination register, and we need to add the two values of the register source, 1 and 2. So we're gonna need to have start1 plus 2. Yeah, these should be pretty straightforward. So these should be pretty straightforward for the most part. The subtraction instruction, we're just changing that. And yeah, pretty straightforward now for these. It should just be a quick change. Shift left logical. since it's an arithmetic shift, it should be the same problem that we had. Not problem, but the same way. So we need to compute the system properly. Systemic cast. This will be needing to cast in signed version of RS1. Right. So signed version of RS1, and then we're adding that to the immediate, not the immediate, the RS2 value. Should be right. We'll just check with the chat so far. Not chat. We'll check with Claude so far. The cast is in the wrong place. Is it not right? Wait, what? Static cast on sending, and then static casting the int onto the register of. Wait, what? Oh, he's just repeating it to me. Oh, okay. Oh, I see what's wrong. I see, wait. So, we need the cast to go here, like this. The full, I forgot, it has to go fully. So now, it'll cover everything. Should be good. I'll just put that in. And look at the add case. I made the same mistake. Same mistake earlier with this. Wait, what? Why would it? Wait, let me go to the add instruction. Okay, it's up here. There it is. All right. These are the registers themselves, right? Not the values inside of the registers, right? And that's at least what I thought. We're just... makes sense. Wait, yeah, I totally forgot. Do the read much. Because we leave the value inside of it, yeah. I'll just replace everything one here. Oh wait, no, let's not do that. Let's not do that. Because each of them have different instructions. Or I'll just replace it. I'll just do this and replace each one. It'll be fine. Yeah, and now let's replace each. Okay, everything looks good. Okay. Yeah, everything looks good. I just need to do it for here too. Yeah. Okay, that should be right. Then we have a couple more to do. Just a couple more. So we have the set less than signed. All right. Second. Right. So set less than unsigned first, right? Is it signed or unsigned first? No, signed is first. So signed. Right. So the signed version. So just like before, right? Okay. So we're gonna store it in unsigned result and have the thing read it. So instead of rs1, if that's less than our rs2 value. So our destination transfer will be 1, if else 0. Should be right. And now for the case of writing it to the register. Alright, let's take a look. So this one's first signed, right? So let's take a look at the thing here. Perform sign compares. Sign compares. So since these values are unsigned, we need to static cast both of them. Just like up here, right? Yeah. And the result itself, static cast it. Since we want the signed value. T. And we want them separately unsigned? Yeah, separately unsigned. So we don't want to, like, we want the operation to be done while it's signed and while it's unsigned, not full sign around the whole thing. So we need to do separate casts. Oh, actually, we ran out of oh, we didn't stream for 2 hours, bro. Wow. I didn't think the music would end. We streamed for 2 hours. We've just been in like flow state, kind of. All right, yeah, it's pretty good. Okay, let's focus again. Let's focus again. Okay, so set less than. Yeah, I forgot we needed a static cast here for this one. Oh shoot, this should be inside. Okay, so now this should be right here, and then we will write the register to the result. Should be good. Should be good here. So I think we're done with the art type, right? Pretty sure. Oh wait, I forgot. We have to do those unsigned version too. But this one is easy. We just need to do that. So less than unsigned. We don't need any static cast since we already have the variable as unsigned. So it will just be the values itself. Yeah, and then take one of these. This whole value, yeah, that's right. Okay, it should be right. We have all our cases now. So I'll give it to Claude and yeah. Hopefully no bugs. Let's see, Claude, no bugs. Oh, we do have some bugs. Okay, let's see. Shift right arithmetic is missing the outer cast. Oh yeah, I have to cast it back. Forgot about that. Casting it to in, we have to cast it right back. Forgot about that. Cast it back to unsigned int so we don't get any errors. All of it. Okay. What was another error that he got? Sorry, is missing outer cast. We did that. SLT cast is in the wrong place. It's in the wrong place. Oh, did I get it wrong? Right. Bro, too many parentheses, bro. It's confusing me. Hold on. So it's this. it should be around this instead. Now it should work. Okay. Dude, that parentheses, oh my god, dude. So many like parentheses errors because of that. Okay, it should be right. Now it should be right. Yeah, well, we will continue that tomorrow since this has been a long stream. 2-hour stream. I'm surprised I even got it that long. I guess because we had people in chat this time, so that drove me forward. So yeah, we'll continue off tomorrow. It looks like we got pretty good progress today, I'm not gonna lie. Got a lot done. We wrote all that. We like implemented enum classes to get all the types way easier, so we refactored that so it's much easier to use. And we implemented part of the interpreter's instructions, so we're just gonna have to continue off with that tomorrow. So yeah, W stream.